Venkana sir, good evening.
Good evening, sir. Is it audible, sir?
Yeah, audible.
Okay, sir. Shall I start, sir?
Yeah, dear participants, there is a slight change in the schedule. So today, first session, the Harinath is from Volume Momentum Company. So he has to take the session actually, but due to his company meetings, okay, he is not able to taking this session. So I requested Dr. Venkana sir from NIT Warangal to take this particular session. So sir has accepted my request and taking this particular session. So sir session has scheduled tomorrow actually. So in place of that, the Harinath will take the session tomorrow. So now the sir is start the session. Thank you Venkana sir for your accepting
Yes, sir.
my request
Yes, sir.
to taking the session. So instead of tomorrow's session.
Okay, sir. Thank you very much, sir.
Yeah,
First,
thank you very much, sir. You can start.
sir, is this my PPT, sir, visible?
Yeah, PPTs are visible.
Okay, sir. Thank you very much. The good evening for all the participants. I have already talked one topic on my previous week, in this week, in a previous session. And the second session, they given the recent trends on the security related. Then I brought the three recent trend technologies, which is one is called SDN. What exactly SDN? What kind of research is happening? I am going to talk because these more or less this particular topic also very well relevant to solve the various security issues which is present in the internet. And next emerging technology is called AIoT. That also I am going to talk. And another very interesting research happening nowadays with the adversarial machine learning models. Okay, these machine learning models are used to provide the security for various network operations. But the question came that these ML models under the adversarial attacks, what exactly that attacks? Okay, if the attack happened, how the ML model is going to be impacted? That all I am going to discuss. Then end of the presentation, few research discussions which really required because most of the participants are from the faculty community or few of them are research scholars so that it will be benefit to them. That's why I brought future research links. Okay, before moving, is anybody heard about SDN? Have you heard what exactly this SDN technology? Anything? Anyone? Please unmute yourself and answer if you know. Okay, fine. The SDN full form is the software defined networks because these are new networking research is happening across the globe, which going to be improve the network performance. Now, if you want to understand the evolvement of the SDN, first the people need to understand how computer system is evolved. Okay, once you are very clear, you are going to understand the SDN evolvement also. When introduced computers are 50 or 60 years ago, some application is going to run, but that application is completely tied up with a hardware which is required. Means, for example, I want to run simple calculator program, that is my application, then the specific hardware is going to be run. But what is the drawback with this particular system? If I want to run new application, then I required new set of hardware to do that operation. That was the challenge. But at least this innovation, they're able to achieve that. They can do certain mathematical operation with help of some hardware. That was the achievement. But the drawback is that for individual application, you require individual hardware. Then what people have started that, yes, means I need to run many applications, but I'm going to use a basic hardware, means some which is related to the computer hardware. But how do I interface? Suppose earlier you have only one application, but here you have multiple applications. Then they started looking or designing of the operating system. So that operating system will act as interface between your user and as well as hardware. Using that particular operating system, you are able to run multiple application on the common hardware. This is a very good innovation because now you are able to run multiple applications. But still, innovation is not stopped. what will happen? Now you are able to run only one kind of operating system, because here you see from single application, you are able to run multiple applications. That is a nice innovation. But people have started, why can't you run only single OS? Why can't you run multiple operating system? That's why at a time means not at a time, means in the same hardware, I can run either Windows or Linux or Mac OS. Means three different operating system you can run, but not at the same time. Once you use Windows, you cannot use Linux, but when you use Linux, we cannot use Windows. That was the innovation. Multiple operating system you can run. And as the innovation happened in the application side also. This is very good. But still, there is a drawback into this particular system. The major drawback is that I'm not able to run the operating system at the same time. Means I want to run Windows as well as Linux. That was the major drawback of this particular innovation. Then people have started evolving the virtualization concept, which we are experiencing every day by installing certain virtual machines, so that while running Windows operating system, even you can run Linux OS. In the Linux OS also, you can run more than one application. Even Windows OS also, you can run more than one application. But the basic hardware is x86 processor. So that is just so generalized. It can run any kind of application. It can run any kind of operating system. And using this virtualization, you are able to allocate the resources according to the operating system usage or application usage like this. This was the innovation happen. Currently, we are in this particular era. You're able to run n number of application. You can run n number of operating system simultaneously, not one after the other. Now, by seeing motivation of this particular innovation in the computer industry, then why don't we do the similar kind of innovation in the network side? Okay. In the network side, what will happen? For example, network applications. In the previous slide, you've seen about applications. Now, here also, a lot of network applications are there. Can anyone tell me one network application which you know? Anyone have an idea? Example of network application. Here, in a computer system application means like you can use MS Office, then you can use Oracle software, and you can use some other software like and so on. Means variety of applications you can use at a time. But when you come to network, what do you mean by network application? Anyone have any idea? What exactly network application or examples of network application? Yes, the examples of network applications, for example, you can take the firewall is one of the example. This is a network application in order to protect your network. Then another network application called routing, and it is achieved with help of router. There is a separate hardware present in the network industry now. In order to figure out protect the network, you have a separate hardware called firewall. Then another, for example, if I want to do switching, okay, among the one network to another network, there is a separate hardware called switch. It's two-layer switching if I want to do. Next, another important network application call, for example, you want to do load balancing across the various servers. You have a specific hardware which is present called load balancer. See that if I want to run one application, suppose here example I have written 4 networking application. You have many more, but for individual network application, I require individual hardware. Obviously, there is a challenging to maintain the hardware for every specific application. Then people are started. What is a major drawback in that? Because the current network industry is more hardware dominated rather than software dominated. There is a one major challenge what they observed. Why it is more hardware dominated? Because now current networking device are manufactured by X, Y, Z, means a handful of industries like a Cisco, Juniper, these popular companies only manufacturing the lot of hardware industries. And the program which they used to run that hardware is also proprietary in nature. That's why it is a less scope for a lot of innovation. Then why don't we, the industry people have started thinking, if you like this, then how come innovation will happen in the network industry? How can we make network perform more better than current system? That's why people have started looking rather hardware. Can we make more software oriented network so that you can manage network very well? If you're able to manage the network very well, can one tell me what is the advantage I will get if I manage a network very well? Any answer from anyone? By managing network very well, what is advantage you will get as a user of internet? Yes, you will get a quality of service. Okay, ultimately, every user is expected. I have taken 1 Mbps of connection, my throughput should be 100%. But in a current real scenario, your throughput hardly 50 to 60% you are getting, because current network or current internet system is unmanageable, means more hardware than the software oriented. That's why I started. People are thinking, then olden days, what happen? Suppose this is a simple router which is manufactured by IBM. In the same router, the application, routing application and hardware and some sort of operating system and hardware completely bounded, vertically integrated with one another. Means for this application, you require this kind of OS. For this application, you require this kind of hardware. Then with the innovation of computer industry, people have started looking in the network industry also. Like, why can't we run multiple application on the same hardware, which is happened here. See, you're able to run multiple applications here on the same hardware. So that what happened, I am having simple white box. Just I am going to provide you a simple white box. Okay. But in this white box, I'm going to give a basic hardware. Basic hardware means what? Some kind of CPU and some kind of memory and some sort of IO. This basic hardware we are going to provide. And you will have some kind of operating system to operate this particular hardware. But that operating system also open source. It can be Linux based or some other open source operating system. Then on top of it, you can run multiple network applications. Example, I can run firewall, I can run routing application, and I can run switching application. I can run even load balancing application and another network application called network address translator. That's why more software oriented than hardware oriented. Then that leads to a lot of innovation. You may have a doubt, sir, what is the advantage you will get by doing a softwareization, which I mentioned here? You're able to manage network very well. That leads to a proper quality of service. That is a starting point. People are looking, how do we manage the internet more software oriented? Then they introduce a technology called software defined network. But don't confuse here. We are not going to change any protocol stack. The protocol stack which you studied in the computer network, like application layer to physical layer, will be part of a host. Similarly, application layer to physical layer will be part of the receiver side. And your intermediate nodes, such as the routers, you have a 3-layer operation, which is a network layer, data link layer, and physical layer, like and so on. But only the people are looking, how do we manage the intermediate devices so that my data will be transmitted to the destination as early as possible. And the current intermediate networking devices, more hardware dominated, so that lead to a lot of lack of innovation. Then how do we improve that? Then people have started just architectural change they have done, but not any kind of protocol change, etc. That's why what I mentioned, the horizontal integration means you have done a lot of vertical integration, but people have done a lot of horizontal integration. Like you have many networking application and you have the common white box. Okay, that's what I mentioned in my previous slide. This is one innovation, how SDN will shape the networking, many networking application which I mentioned, right? This innovation, and this I have also mentioned, right? Now, this is one part of motivation why people are coming up with a SDN technology. The second major innovation people have started. Now, you have a lot of intermediate routers between your source and destination. Suppose this is your source, which you are sending the data. Now, this is the destination, which is receiving the data. Your packet is going to travel lot of multiple intermediate networks. But the problem is that whenever your data is traveling across the multiple networks, uh, generally that data will be passed through the routers, like router R1, maybe R2, like router RN. Okay, this router generally operate a three-layer device, which is a network layer and as well as a data link layer and as well as physical layer. Fine. But majorly in the network layer portion, because the moment packet arrived to this particular router, R1, this router R1 is connected to R2 or also connected to the another router, for example, here R6, and it also connected another router, for example, R7. But the moment packet coming here, this router has to decide whether I have to place the packet in this interface or this interface or this interface. How this particular router will decide how do I place? By looking routing table, by looking routing table. Now this routing table entries got filled by executing routing algorithm distributedly on event based or regular update based. The moment packet comes, I'm going to inspect the destination IP address. Then using the destination IP address, I'm going to search in my routing table. Then if I found, yes, if this particular packet want to reach this destination, you have to use this particular interface. Fine. Means this network layer do two basic functionality whenever you want to forward the packet. The first basic functionality is called routing. Now, second basic functionality is called forwarding. Okay. Once the routing is decided, the forwarding job is to take the packet from input interface to outgoing interface. That's why network layer at the intermediate nodes to do two jobs. One is routing and forwarding. But this routing is also called control plane operation. This routing is called control plane operation. This forwarding is called data plane operation. Two operations happen. Yes, generally the control plane will sit above and data plane will sit bottom. These two operations currently happen. But what is the challenge with this? For example, now you decided your path of a packet R1. Let us take a scenario R1, R5, maybe R7, R9. Like this, your path is decided. Let us assume. But your path is decided when I want to push the data. But when real time, when my packet is travel at router R7, the link between router R7 R9 is congested. Because of the congestion, what will happen? There is a chance my packet got delayed or my packet are dropped. Then what will happen if the packets are dropped? The quality of service is going to decrease. Quality of service is going to decrease. But do I know that this path is congested? Yes, initially I don't know whether my path is congested or not. But this happened at the time of dynamic of the network. How did you decide it? Because routing algorithm executed, then routing tables are calculated because network condition is dynamic, time to time it is going to vary, no doubt in it. That's why the people started the second innovation to make network more manageable. Why can't we place this control plane in centrally? Instead of keeping distributedly, why can't we place in a central location so that the control plane operation will happen in a single place? So that the control plane operation also having the complete global view of the network. Yes, this particular path is congested. The control plane time to time get the information from the individual routers so that your path is priorly planned between R7 and R9. Now I came to know that there is a congestion in that. So that time to time I can say that From R7, you can redirect the packet to R8, then R8 to R9. So that what happen, at least your packet will be delivered more or less near time to your destination. Okay, that's why second innovation they have done, the control plane they brought into a single entity to get a global view of the network. But your individual router right now means if the SDN architecture practically is going to be implemented, just only you have the forwarding plane. The forwarding plane means the controller time to time it is going to be instruct me. Okay, because controller having the global view, but how controller knows that time to time is going to query the individual routers. Tell me what is the congestion level or how many packets you are processing, what is happening at your end. Time to time control is going to talk to a routers. Then routers give the complete information. Okay. Based on the complete information which I am receiving from all individual routers, so that I can decide perfect path to travel your packet from source to destination with less experience of congestion, so that you are able to manage your network properly. That managing of the network leads to a good quality of service. Because please remember, now which you are experiencing in the daily internet, suppose you are using a WhatsApp, if some image got delayed in your, it is streaming, assume it, you will got frustrated. So why it is? You are expected that the moment I click the image, it should be displayed on my phone. That's all. That is your expectation. But that is not reaching in the current internet. Because why it is happening that? Because the network is not manageable. Because you are not monitoring time to time, and what is happening you don't know. So that what is the ready-made path is decided, accordingly packet is traveling. That leads to a lot of uh, improper network management that leads to a quality of service. But right now, every user is bothering whether I will get internet connection or not. But in future, means down the line 5 to 6 years, the internet connection is not a big challenge. Who provide a better quality of service, you will go and get the internet connection from them. That's why people are in future is going to bother more about SLA, service level agreement. What does it mean? The ISP, internet service provider, example like a BSNL, Airtel, Geo, like and so on. When they provide internet, they mention that, okay, if you're using multimedia traffic, the end-to-end delay, I'm going to mention 0.5 second, right? Suppose you are doing just a email communication, end-to-end delay 0.3 second. This is the agreement you are going to do between you and the between ISP and the customer. So that once I did agreement, if I am not able to deliver, then what will happen? Your quality of service is degraded, so that tomorrow the customer will not attach to you. Like you're seeing olden days, you might have experienced. If you purchase a SIM from BSNL, you more or less you be with BSNL anytime. But now technology came that yes, you taken from connection SIM from BSNL. You no need to stick with BSNL for a long time. If you're not satisfied the services, you can switch over to Airtel anytime. There's a lot of dynamics came so that the competition in the business, that ultimately the service provider always look how to provide a good services to the users. Now in future also that will happen to the internet in the form of SLA. But how do we achieve that proper SLAs? Only solution is the managing of your network with help of technology called SDN, software defined network. Means keeping the control plane in the central view of the network and manage your network properly, that gives the advantage of service level agreement, which I mentioned. Every network layer do two jobs. One is called routing and as well as forwarding. Generally, routing means determining the end-to-end path. The forwarding means taking the packet from one interface to another phase. The basic difference also brought for understanding purpose. The forwarding job is to take the packet from one link to the another link. Means suppose assume that this interface take the packet from ear to ear. There is a call forwarding job. But whereas the routing job, suppose your packet want to reach to the destination, you're going to completely decide a path before packet is traveling. That is a call routing job. That's why it is called computing the paths of the packet will follow. The forwarding job, it is a local, and global, it has a global view. That's why, as I mentioned, the control plane operation brought into a single place. That's why it is called controller, which manage your network. Then under the controller, you have only the routers, which takes the packet from one interface to another interface. This job will be done by routers, but in SDN technology, this router is also called three-layer switch, because you're no more doing routing job, because routing job done by whom? Controller. That's why these routers are called three-layer switch. Okay, three layers, because it's just doing a switching job from one interface to another interface. That's why in a traditional internet, every router will maintain a routing table, but here every three-layer switch maintain a table. That table called flow table. Please remember, flow table. And every flow table maintain a flow entries. Every flow table maintain a flow entries. But these entries, the time to time, get filled by controller. Means what will happen? The moment a packet arrives here, okay, this particular sequence of packets or group of packets, I'm calling it as a flow. Why I'm calling flow? Because all these packets having the common header field information. Means these all 10 packets or 20 packets are targeting to the same destination. So that if the same destination means it is obviously generated from the same source. Means source IP address, destination IP address is a common. And as redirected to the same destination, you are using a common port number, like and so on. Many fields having common. That's why I'm calling these particular packets called flow. Now, some flow of packets are arrived to a particular router. Assume that this is a router R1. Then the moment flow of packets arrive to a router R1, I'm going to see what is the destination IP address of these all packets, all these all flow of packets. Then I'm going to search in a flow table. If the entry is not there, what will happen? This router will send a request to a controller. Yes, now I have 10 packets, but this 10 packet want to send to this destination. I don't have any flow rule. Will you provide me any flow rule to me so that I can send the packets? Then the controller search in his global view of the network and give the flow rule. Then flow rule will be filled in the flow table. Means the time to time, this three-layer switch is going to communicate to the controller. But in internet, any communication will be defined called protocols. Yes or no? Any communication in internet, because machines are communicating. When machines are communicating, you should define that communication with help of program. Means define a standard, what procedure will be called, next what procedure will be called. That is called protocols. That's why the communication between the switch and controller is called southbound interface. Southbound interface. And for southbound interface, we have a de facto protocol present as of now for in SDN technology is called OpenFlow. OpenFlow protocol is present. Using the OpenFlow protocol, time to time, the packets arrive to the particular router, and using OpenFlow protocol, you will take the packet to a controller, get the flow entry. Flow entry will be filled in the flow table. Once the flow entry is filled, your all 10 packets will be processed. Suppose the next set of flow of packets arrived. Once again, I am going to search in the flow table. If it is a hit, I'll forward. If it is a miss, I'll go to a controller, like then get the flow entry. Like that, time to time, you're going to get the entries from the controller. The controller time to time observing the dynamic of the network. If anywhere any congestion happen, is not redirecting the packet to that path and is redirecting to the another path, so that you will achieve a better quality of service. Then forwarding job, it is implemented in hardware. As I mentioned, controlling job, it is implemented with help of program. That's why it is called software based. And forwarding will happen oftenly. That's why it is called nanoseconds. Generally, routing will takes place because once the path is decided, path is not going to compute very frequently comparatively forwarding job. That's why the execution of the program like this. What I mentioned, data plane and control plane that you already got this about. Now, as I mentioned, the current internet, why people are moving from the traditional network to the SDN, what is the necessity for that? Here I have mentioned some reasons. The current hardware is a closed equipment, means it is not, because if a particular device is manufactured, means it is manufactured by Cisco. If some error happened or something you want to know internally what is happening in the device, you cannot see, because only Cisco engineers knows that particular programming language. They can only do that. But as I mentioned in my previous slide, you are going to give a common hardware. Okay, on top of it, you can write your own program. Then if you are writing a target programming like a router, you can write that particular device is going to act like a router. Okay. Okay, then if it is want to like a switch, it is going to act like a switch. Like that, it is going to happen time to time. That was a major challenge in the traditional internet. But whereas SDN, your equipment is open, you can introduce any kind of new protocol which you require. Because today, maybe standard protocols are available like a TCP and IP. Tomorrow, some new protocol somebody want to invent. But in order to execute that new protocol, your underlying hardware is not going to be supported, because your hardware is designed to execute a specific or set of protocols which is present popularly in the internet. Now I have introduced a new protocol, all of a sudden I want to run, but it cannot be real-time deployable. But if I make a common hardware, which is a white box approach, then you can invent your own protocols. Then maybe that protocol may be useful to manage your own network that may require, because your network specific requirement may be different comparatively other, because the whatever the network requirement I have might not same into the another global network. So that you can invent your own network and do that. That is a called closed equipment challenge, but it is completely is going to come up with open equipment. But this SDN technology already implemented in a Google data center like that. Now, as I mentioned, slow protocol standardization, because so many protocols might have designed, but that all protocols are unknown to us, because those protocols are not practically implemented. In order to implement practically, hardware will not support. And as of now, this particular internet, traditional internet, only few handful of members are participated, like as I mentioned, Cisco, Juniper, like and so on. They cannot, and they have their own vendor-specific programming language. Even you cannot understand what exactly that code. Because if you write a Python, you can easily very well read and understand and execute it. But they designed their own coding language, because they need to understand with their engineers, not for everyone. That's why long delays. That's why a lot of innovation is happening from traditional network to SDN. Even with this innovation, your network is going to be very well managed. And very well managing, another important is that in the current internet, a lot of security issues also can be resolved with help of SDN. Why? Because if SDN technology implemented, you are having the advantage called deep packet inspection. This is a very beautiful advantage with the help of SDN technology, deep packet inspection. Now, when you are deeply inspecting the packet, means every packet consists of two parts. One is called header part, and second one is called payload part. Because you will not bother about payload, because payload is encrypted at source and able to decrypt at the destination. That is general phenomena in the internet. But in the current traditional internet, you can see the header information, but you cannot analyze it. Okay, if you are able to analyze it, some sort of security issues can be resolved. Now, if you're able to resolve, you're going to achieve a security of internet even more better and best way, so that end-to-end secure communication will happen. This innovation is happening. This is what about SDN technology. The motivation for SDN, as I mentioned, I'm going to talk the emerging technology. One is SDN and AIoT, and as well as adversarial network. The probably first 30 minutes I said I'm going to talk about SDN. This is the last slide related to SDN. The main challenge of the SDN, your resources are many because day by day, if you need 1 Gbps, you can available in single fingertips. You need 10 Gbps, it is available. But only challenge is ability to map resources with workload time to time is a big challenge. Means how do we map resources with workload? When you're able to manage your network very well. That responsibility taken to the SDN technology, then which provides a good quality of service. This is about SDN. Now I am pausing for 2 minutes. If anyone have any doubt, they can ask. Because very briefly I talk, even we can talk many hours, but in the interest of time, I have explained only 35 minutes. I am pausing for 1 minute. If anyone have any doubt, they can ask. Okay. If there is no doubt, let me proceed further. This figure I have explained you in my previous class only. But this particular figure explains the basic structure of the IoT. But right now, the IoT technology, in the second version of the IoT technology, people are calling about AIoT. Means AIoT means by combining the artificial intelligence with help of IoT. Nowadays, if you see any research paper, that research paper is targeting the output or research in the AIoT only. Now, with help of IoT technology, you're able to connect the physical object or things to the internet so that you can sense the information what is happening. Once the data reaches to internet, you can analyze it. That's what is happening. But the problem is that the physical object which you are sensing, it does not have any intelligence in that. Just does only sensing job. Then people have started thinking, yes, it is very well sensing. Now, after sensing, can it think and take necessary decisions then and there itself? But if I want to take a necessary decisions, but what he has to do, whatever the data generated from the physical properties can analyze the data then and there itself. Because as I mentioned in my previous slide, once the data store into a cloud, you are going to analyze. From the analysis only, you are going to generate required insights. Okay, you are going to generate insights. These insights is help us to take the decisions. Yes or no? Then people have started thinking, why don't we analyze the data at the generating of that? Means why don't we make your devices? Means currently your devices is a just dumb devices, just is collecting the data. By integrating AI to the devices, can I make those devices or smart devices? Like example, if I want to give analogy, few years back, we used to call just CCTV camera or CCTV camera. But right now we are in the market, it is available, the word called the smart CCTV. What is the difference you found? In the olden days, CCTV job is to collect the frames or collect the live video, feed it to a cloud. That's all. But right now, your smart CCTV is not doing that job alone. Along with that, now we wrote certain deep learning means in a smart CCTV, not me. In the smart CCTV camera, they wrote a deep learning algorithms which required to recognize a person. Yes, is this person is authorized person or not? If this person is authorized, then door will open automatically. Then after capturing the image, analyze the image, Yes, after analysis, this image is not authorized person to enter the house, then indirectly lock is not going to open, or some sort of alarm is going to happen so that owner of the house can find out, yes, some unwanted thing is happening so that he can be alert. But how it happen with help of smart CCTV technology. Okay, to make the smart CCTV, what is the background? You have a certain AI algorithms. That's why AIoT major innovation, how to make the dumb devices to a smart devices so that it can analyze the data and do that. Now, when I integrate IoT and AI, now generally your devices are going to generate the data and you are going to collect it and you are going to analyze it. Just now I mentioned act analysis. Like if the person is authorized, you allow it. If the person is not authorized, don't allow it. That is a call acting. Not only that, you are with help of lot of visualization tool, you can keep track how many authorized persons enter into this house. Means summary chart can be given whenever you required in a single tip of the decisions like this. Now, as I said, what is mean by smart? Okay, you are able to take a decision. You have a two choice, whether I have to go left side or right side. That how you will able to do that? The choice, how it will be decided. Then when you become a smart or ability to take the decisions. But the thing is, when you will be able to take the decision, when you have the proper data, when you have a proper data. But how you will able to generate this particular data? With help of a sensor technology or IoT technology like that. Means if I want to make my decision smart, the IoT is going to be very important. That's why AI plays a role to make the decisions automatically based on the modeling of the data, which I just now give an example. I model that this particular user is not a authorized user, then I am able to take a decision. Now, as I mentioned, there is a thick relation between the IoT and machine learning. IoT is a primary source for generating the data. Then machine learning use that particular data and analyze it. That's why they go hand to hand together, means one depending on another. So that leads to a strong, a new technology called AIoT, which I mentioned. That's why here you can see the machine learning and Internet of Things is a complementary each other. Means they cannot work individually. They need to work together so that much more smarter solutions are going to come up in future. Generally, when I say AI algorithms, you previous speakers might have already spoke about it, but I'm just give an example in this particular context. Generally, AI algorithms' job is to percept, means pursue the images and learn from the data and give necessary reasoning, means outputs, right? The goals of IoT by merging IoT with his job is to collect the data and transmit the data over internet and processing the data and give the output which is required. That's why both are interrelated. These I have already mentioned, like one example figure I brought here. You are sensing through certain sensor, then you are learning. Once you learn, you are going to act it. Then you are going to get some sort of comprehensive decisions, allow or not allow. Then once again, it is a loop, sensing, learning, and comprehensive solution. This is a continuous process. Generally, it is going to happen. But I said very nice. But if I want to make my solution work at the data generation place, the new technology which people are talking about, edge computing, means in IoT, whatever you've seen, for example, this IoT device one, and you have the IoT device two, like you have multiple IoT devices. These IoT devices are going to send the data to a gateway. Now, gateway is connected to the internet, then data is transmitted to the cloud. But in general, what is happening before AIoT technology, your data all the way transmitted to a cloud, decisions happen. Once again, generation is your decisions are going to retransmit to the source of the data. But with help of edge computing solutions, because edge computing concept they have introduced, then they started looking as edge computing technology is there. Why can't why can't we take the decision at the data generation place? That is a call AIoT. That's why now if the decision happen at the cloud, the major drawback is that it takes a lot of time to transmit. While transmitting, there is a possibility your network is congested, then there is a chance of drop the packets, then decisions will not happen. Next call fog. It is not near to the data. It may happen little far away. Example, when the fog technology happen, assume that your decisions are takes place in the gateway, but that also takes little bit amount of time. Instead of that, can I do at the data generation place? As just now given example, your video is captured by CCTV. Now, can you process in that image at the CCTV, come up with some kind of solution that is possible with help of edge computing based solutions? There's a simple difference. And when I say AIoT, means yes, the story is very nice. You can compute, you can generate the data and take the appropriate decision then and there itself. But how that cycle is working indirectly in the background, because if the computing technology is not happen in the sense olden days or even certain prototypes you are using node MCU, okay now, but node MCU is job is to interface few sensors, and node MCU having inbuilt Wi-Fi, it can transmit the data to a gateway. But this node MCU not having the capability to run the sophisticated machine learning algorithm or deep learning algorithm. So that if I use node MCU, I cannot achieve with AIoT solution. That's why people nowadays using the sophisticated hardware resource like Raspberry Pi, NVIDIA boards, like and so on. Okay, that is available in order of 10,000 or 15,000. But this particular Raspberry Pi or NVIDIA boards having the lot of capability to process at the data generation means computing side, lot of innovation is required, and communication side also, because the moment your decision happen need to be intimated, and sensing side also, because you need to sense every second or every minute order of that, so that that will be fed to your algorithm, then communication. With these three advancement of the uh, three technologies integration, which leads to a AIoT that is achieving in nowadays. Like one example I brought for understanding, maybe you are experiencing nowadays with the smartwatches, yes or no? Now in the smartwatches, what is happening? Maybe some sensors are present in the smartwatch. Okay, that sensors, example, you can take the accelerometer sensor, the gyroscope sensor, and magnetometer sensor. Now, this accelerometer sensor give the acceleration, means how much speed you are moving, at what angular velocity you are moving, either you are bending left, right, or how bendings are happening. And accelerometer, sorry, magnetometer, it gives the certain magnetic field impact of that, means you are close to certain object, etc. Now, this particular data given to a basic classification machine learning algorithm such as CNN, RNN, which is part of like a sophisticated smartwatch, so that now you just hold that particular watch to you, hold that watch or wear that watch to your hand and sense that particular data. Now it is sensing time to time action takes place, and it is able to give that today you've done 10 footsteps. Today you've done 10 times sit-ups. Today you have done your bended left side maybe 100 times, or all of a sudden you are fallen down 5 times. Means how they are able to recognize your how they are able to recognize the actions, because background there are AI technology. But if I want to run that, if I want to come out with insights, background you require sensor technology. These are simple example. Another widely accepted example is called AIoT. This is another example, which in the interest of time, just this is about AIoT technology. But what I want to say that by integrating AI with IoT, you also having a lot of advantage. We are in the era of using or adopting this AIoT technology. Then generally, when you go for any AIoT technology, the model development is this life cycle. You know very well. I need not reiterate. This is a basic life cycle of model development. How do we optimize and etc. Right? Very good. Now you are developing the machine learning model. Okay. My second part of lecture is over. Anyone have any doubt? They can ask me. I'll pause for 1 minute. Just I'll pause for a minute. Okay, anyone have any doubt? Okay, if there is no doubt, let me move forward. Yes, very nice. The story is very good. The other side of the coin, AIoT is bringing a lot of advantage. Very good. That if I want to make AIoT successful, the background is some sort of DL model. Okay. Now you are completely relying on this DL model. You are feeding certain data based to your DL model and is giving action A means something happen, action B means something happen. Yes or no? Fine. But another adverse thing is happening is called the adversarial attacks. Adversarial attacks. These adversarial attacks makes your ML or DL model give you a wrong decisions. Give you a wrong decisions. Then if it is giving a wrong decisions, then that is a question of your DL model working, right? Then how do we do that? What is a wrong decision happen? What way attacks are happening? That's what the discussion point here. Okay, how it is going to happen? These all we are going to discuss here. Just I'm pausing for a minute. Sorry. Now, as just now I mentioned, whatever the AIoT technology, these are called smart TV, and these all the moment smart CCTV, and as well as hope my voice is visible, audible. Sorry. Fine. Now, the moment this data, these are AI-based AIoT solution, edge IoT solutions. Sometimes your AI model present in the cloud also for taking the decision. Now, what is the problem with these machine learning models? Let us take example here, how adversarial attacks happening, you can see. Suppose this is a pig image. Now, taken a lot of images from the data set, developed some sort of DL model. Then the moment your model is trained well, then if I give a pig image to your model, is able to classify, yes, this model is this particular image is a pig image. Fine, very good. But what exactly it is happening? See, just I am adding certain perturbation, means I'm adding noise to your image. You can see generally this image, if I convert into pixel background, this is the way it is going to happen. Means I'm going to take a pixel value, either I represent in a 2D matrix or 3D matrix, depend upon the image type. Now, this pixel value, assume that is a 10. Maybe in this case, the pixel value is a 20. In this case, the pixel value is a 30, like and so on, right? Now, what will happen? I have added some sort of noise to this particular value. Suppose 10 plus 10 I am adding. Then what happened? I have changed the value to 20. Like that, randomly, I am going to pick up certain pixel position, add the noise to it, so that values are going to change. But your front-end image looks like a pig. Now, after noise adding, there is a call perturbation of the data. Then the noise added image, if I feed it to my trained deep learning model, what will happen? This trained deep learning model is giving output instead of pig, called airliner. See that your model is completely full. Then if you rely on such models, then decisions are going to come up with a wrong. As just now I mentioned, like a smart CCTV camera, suppose if this person means it's the owner of the person, if not unauthorized person. But what will happen? You perturbated the data, then image classifying instead of actual owner to the unauthorized to authorized. That issue is going to come up in a future because completely we are relying on the machine learning model because a lot of research is happening on this area, which is started research in 22, 23. That's why no doubt ML models are used to solve the security issues. But the problem is that there is a security issue on the ML model. Then that how do we address? Okay, this is a general ML model training figure, which I mentioned in my previous slide also. In ML models used for a lot of security solutions like intrusion detection and prevention and malware identification and anomaly behavior data, or if any URL is malicious, it can be detected like keep captcha based. Many solutions are used. Now, as I mentioned, a lot of ML models is under the security problem or data perturbation problem. See, here I have represented one figure. Just see that, suppose this figure A is there, and as well as you have the figure B also, as well as you have figure C also. Three figures are there. This is a part one, then this is a part two, this is a part three. In a part one, in general, what will happen? You are training the model, training process takes place. Then your model objective is to classify the object. Then once it is a classification happen, you're testing with a new data so that is able to take a decision. Yes, this is a pig or not a pig or something else. This is a general machine learning process. But in order to make your model not performing well, various methods are there. What happen in order to make your model fooled? Now that input data which I am giving, there is a corrupted input data I am giving. Means by feeding the wrong input to your model, what will happen? It gives the wrong decision. It is similarly like where we are telling example always to your kids or your students. You be with a good students, not with a wrong student. If you with a wrong student, what will happen? Slowly the wrong student will inject the unnecessary or unwanted data to the particular child mind, so that one or another day the child also become unwanted person. Means you're feeding with a wrong information. Similar manner, then what happened? That child is started misbehaving. Similar manner, as you are trading with a wrong data, your model is going to be fooled. Then your model is giving corrupted decisions. You can see here. Okay, now you are not training the model in a wrong, in another way, how to fool the model. You are giving a correct input. But what happened? Whatever the model you have trained, ultimately, when you train the model, weights are going to be generated that you know very well with help of any deep learning or machine learning point of view. What I'm going to do, I'm going to change the weight values. For example, when I train the model, assume that your weight value is a 0.3, but I am able to access the model. I am attacker. What I'm going to do, I'm going to change that 0.3 value to 0.4. So that what happen, you even though you feeded correct input to that, but your model weights are changed and it is going to give a wrong decision. This is the another way you're going to perform attack on machine learning models. This is a called adversarial machine learning model. Now, if the adversarial attacks happen, what will happen really? The major impact it is going to happen in autonomous vehicles. You are seeing nowadays, autonomous vehicles are completely relying on the machine learning models. Why? Because autonomous vehicles should sense the objects, classify that object as something, take appropriate decision. Example, suppose you are moving, your AV is moving, in front of there is a sign symbol saying that left. Then your machine learning model should recognize there is a left direction, take the left. Fine. But what happened? There is I kept the symbol as a left sign, but what happened? I have done certain indicate some changes in that particular sign symbol. Means I perturbated physically I perform attack on the sign symbol. Just I put a small stickers somewhere in the physical sign symbols. Then what will happen? Your sensor is sensed, but because of it sensed the wrong image, your sensor your machine learning model may classify instead of left decision, right decision. Then what happened? You may reach it to the wrong destination. That's why in the autonomous vehicles, the adversarial attacks creation and mitigation is going to be active research. You can see in the internet, very recent papers are published on this particular domain. Even medical imaging, we are completely going to be rely on suppose let us take, you've taken a cancer data set and trained it. Nowadays, the understand or well-defined deep learning models came to accurately classify what type of cancerous it is. But if I made some adversarial sample creation on these particular images, then it may create that wrong diagnosis. Even though you have the cancerous samples, it may give the wrong output is no cancer, vice versa. Even though no cancer, by perturbating the data, your model is fooled. Then if the model is fooled, it gives the wrong outputs. Even a lot of facial recognition, which I mentioned just now. Okay, actually the person is not authorized, but I have done data perturbation. Then your model may take authorized and allow him to that. And a lot of cybersecurity issues like a CAPTCHA, these all is going to happen. And generally, yes, sir, you were telling, is this very easy to do this? But there are various ways you can create adversarial samples and perform adversarial attacks. Okay, how we can create it? You can see here a lot of adversarial samples. You can see either if you want to create adversarial samples, you can perform white box approach. And second way of adversarial sample called gray box approach. Now third one is called black box approach. What does it mean? Now, whenever you want to perform adversarial attack, generally you are going to use you are going to perform on machine learning models, right? Then white box based adversarial sample creation in the sense, whatever the machine learning model you train, attacker having a complete knowledge of that. Attacker having complete knowledge means what type of model you have used, what type of data set you have used. After training, what is the weight values, everything attacker also knows. Once the attacker knows, Then if attacker is able to create adversarial sample and succeeded, then that attack called white box based adversarial attack. Now, second, the gray box based means I might not have the complete knowledge of your model development. Maybe I know what data set you have used. Maybe I know what machine learning model you have used. But really, I don't know after training what could be the resultant weight values. Means have a partial knowledge about your model. Then with help of partial knowledge, if you're able to create attack, then gray box based adversarial sample creation. Then third one is a called block box. Neither data set nor model trained parameter, model type, don't know anything. But still you're able to create a adversarial sample and perform attack, then your attack success rate is very high. Your attack success rate is very high. Once your attack success rate is very high, your model no more give the correct decisions. But most of the research currently publishing in the research papers, they say that block box based adversarial sample creation is going to be a very active research because you don't know. Because suppose I developed a smart CCTV, right? Now, what predefined neural network architecture you have used, you don't know because just your end user. Some companies told me, then feeded that I have taken proper biometric of authorized person of house, then just feed it to the model. Then I am saying very well, your CCTV will authorize only your house persons. It will say that unauthorized. Just I am an end user. I'll bring that particular product and deploy at my home and make use of it. But what internal model used that is unknown to you. But attackers can take control of that smart CCTV and create certain adversarial sample. And if it is a succeeded, that is a block-based adversarial sample. Now, generally, this adversarial attacks, whether it is a block box approach, white box approach, or gray box approach, then how do you perform attack? How do you perform an attack on adversarial sample? The first thing is called poisoning. Means at the time of training itself, you are going to feed with a slight changing of the data samples. That's why poisoning of your labeled data. So that suppose assume that you trained 1,000 images. Out of 1,000 images, maybe 100 images you are perturbated and feed it to your model so that your model may take wrong decisions. That is a called poisoning attack. That's why I at the poisoning point. Then another type of attack called evasion attack. What exactly this? Here you are not going to add the perturbated sample at the time of training, but you are able to create the perturbated samples at the time of testing side. Let us take simple example here. This is a stop sign, which popularly used in your AVs, autonomous vehicles. But what happened for this particular image, just I physically sticked a certain green symbol here, okay, and some yellow patch here, and some orange patch here on your stop sign, you can see here. Either you are physically or at the time of data feeding. But when your AV sensed it, then what is doing is sensed it as a green light. Then what happened instead of stopping, your vehicle is moving. Once your vehicle is moving, there is a chance that vehicle may be met with accident so that it is going to have loss. This is called evasion attack. Means at the time of real-time testing, if you perturbated the data, there is a called evasion attack. But this is also one kind of attack on the machine learning model. The example which I shown for poisoning attack. Now at the time of training itself, you are adding the wrong data samples. This is a red color you can see, so that you are able to do perform attack. And another type of attack, which I very popularly happening, not only evasion and poisoning, like model stealing means you're able to extract the model parameters. Means you don't know what data set you have used for training, but if I extract the model parameter by querying, it is simple example if I want to give analogy, simple analogy if I want to give. For example, I want to know your password. I know that you are more inclined to, means more uh, lovable of father, mother, etc. Then I'm just querying, can you tell me your father name? And querying, can you tell your mother name? So that I able to collect your two parents' information. Now I can make the password out of it and try it so that I might have succeeded. Suppose you are not succeeded, then later you ask what could the date of birth year of your father or what could be the date of birth year of mother. Then combination of that I tried, then I might have succeeded or might not. Okay, like that, the lot of query is going to happen. You are going to query the model so that you will able to extract certain model parameters. Then you are able to build your own model. I mean, that's why you're able to build the model. There is a called stolen model. Once you're able to build the stolen model, you can perform some sort of attacks. These are way also going to happen. This is another type of attack like membership inference attack, like seek determine whether the particular data record was used in the training set or not. There is some sort of querying so that you will able to understand. Then this is another, which I said, model inversion attack. What happened? These are target model which you developed and deployed in the certain device. Now, if you're able to query certain questions, you will get a query weights of the parameters. By seeing the weights of the parameter, I am able to construct a person image. Because in the any model, weights only private. Weights of the is the private. If you're able to know the weights, you can easily infer the data behind that particular weights. Data behind the weights means you can construct the image once again. Now you constructed image, then you feed it to your model, you got John Smith. You don't know the anything, but you just extracted the weights and reconstruct the image and feed it to your model. Then you feed it actual image, then you're able to get the access grant. That's why adversarial machine learning is going to be a very active research, and as well as if adversarial machine learning is going to be uh, used everywhere, or attackers are make use of this and started performing, your models are going to be failed time to time. But please remember, sir, is that much easy? Your question is that, is it possible, whatever you're telling, is it just a hypothetical scenario or practically? I'm saying it is not hypothetical, but model developers are carefully designing the models, but still there is a glitch in the model development, etc. By taking that 0.1% or 1% or 10%, people are able to succeed at the adversarial attack creation and model fooling. That's what the research articles are publishing and showing the results also. These I have mentioned in the previous slides very clear. Like you are seeing, these are called fake news attack, which you have experienced or heard the Barack Obama. Okay, but he's really not given any such view about something. But with help of lip movement, somebody feeded wrong data, means adversarial sample is created. Then it is visualized that really this Obama is given these statements. These also you can easily understand. These I mentioned. Okay, but how that adversarial models are going to be really impacted? It gives the incorrect prediction images. Means if we give incorrect prediction means your ML model is not at all working. Straightforward, it is rejected. And decrease the model robustness, like actually your model supposed to be accurately perform, give at least 99% of accuracy. But by model evasion attack or model poisoning attack, your model is misclassifying so that your accuracy is dropping down maybe 90%. So that model robustness and reliability is there. Not only that, if the model predict wrong and reliability, no problem, but it leads to a lot of security risk. Just now you've seen a small sticker on stop sign. Instead of taking left direction, he has taken right direction. That leads a lot of security threat. He might with accident or something happen. If the models are not performing well, it lose the trust. That is very important because AI is going to be emerged, no doubt. We are going to be completely rely on AI models, but completely relying on the AI models, nothing mistake. But the caution is that if the model is started giving wrong decisions, you may lose trust on the AI models. That's why it is going to be created. And there is another problem of transferability attack because your adversarial attacks are samples are created in one model, maybe might not be impacted on the model, but it can be impacted on the another model which is part of same solution or another kind of solution. That is also going to be a very serious impact which is happening. Okay, these adversarial attacks, how it is going to happen, you can see in this that I have mentioned. See in the network data, how can you create adversarial samples? You can see the network data, generally it consists of packets. See that actual IP address is this one. Small change we have done. Instead of 5, just I created a wrong data. And instead of port number 443, just I have perturbated to 442. I mean, this is your original sample, but I have manipulated. What will happen? Sometimes your model accurately classify this is wrong, but by manipulating this data, your model also can be fooled and taken a wrong decisions. This is the adversarial attack, how it is going to be. Anyway, I'll try to share the slides with you. You can easily understand. And in this also, we have tried to provide a small solution. But in the interest of time, just whatever I have explained in a similar manner, we created an attack so that we are able to succeed it. But not only that, we are even after succeeded, even though means generally when you go for attack adversarial samples, always people show in results how much your attack success rate is happen. But whatever the solution we provided, even published in a good research avenue, and we proved that, yes, it is seriously impacting. Then even not only seriously, means we have done both. Adversarial sample creation is our contribution, right? If your adversarial sample is so dynamic, even my model, means whatever the model we are developing to mitigate these adversarial samples, so that you create any kind of adversarial sample, my solution is going to be determine these adversarial sample and stop the traffic or etc. So that your model robustness, still your model accuracy is going to be maintained or attained 19%. That's why 2 cases. We did 2 research questions. How do we create a effective adversarial sample and how do we create a mitigate them? That's what our contribution. This is a simple thing. Right. Now, as I said, every time, whenever we are working, what could be the future research direction from the whole, these 3 interesting research areas, particularly part 2 and part 3. How do we make, suppose if you want to make AI OT to protect the security, etc., how do we make lightweight and energy efficient solutions is very going to be important, because as of now, your models are installed into the cloud so that your model have the ample of resources so that it can run any point of time, can give decisions. But in future, your models are not going to be executed, maybe trained at the cloud, but it is going to be readily deployable at the edge. Once it is readily deployable at the edge, it should be lightweight and energy efficient, because your edge devices are not connected to the internet. Your edge devices are not connected to the complete energy resource, so that your model should take lightweight. That's what I mentioned, edge AI solution and federative learning security. And context aware about adversarial defenses. That is a very important, because whatever the model, whatever the perturbation data I have created, maybe in this context, may be correct or may be able to detect, but in another context, not able to detect. But how do we classify, even though this type of attack happen, how do we detect that? That is also another active research which is present. These all research questions I brought from the recent research papers as a future direction. And dynamic and adaptive threat modeling. These are very important. Adaptive in the sense you developed a defense strategy, but the defense strategy might not applicable in a second scenario, might not be applicable in a third scenario. That's why we always give example. The person should be always adaptive. It should not be a static. In a similar manner, whatever the defense strategies you are going to define, how do we create the adaptive threat models? Means new attack comes or new adversarial sample is created. At least your model able to detect, yes, this adversarial sample might not in the first instant, but in the due course is able to detect, yes, there is adversarial sample is creating, then need to be find out. And another issue is that, which I mentioned in my previous discussion also, the major problem, this new adversarial sample creation, etc., because of lack of real world IoT data. Means few data sets are popularly used, but the few data sets attack diversity is very less. If the attack diversity is very less, your model might not train with new new attacks, so that it cannot be adaptive, so that people can look into this particular direction. Means my concluding statement is that ML models, no doubt it is going to be very good, but the thing is achieving robust and privacy preserving is going to be challenging. Then people robust in the sense, if the adversarial attacks happen, your model reliability is coming down. And if the model theft happen, I'm able to reconstruct your private data. And trustworthy, because you are completely relying on the AI, but or deep learning models or machine learning models, but are they giving correct decision or not? The major another research, real world validation is also a big issue. And trade-off between the robustness and performance is also. You say that my model is better, but will it perform less constrained resource environment, so that your performance is coming down? That's why somebody can look, okay, your solution should be a robust but limited resource environment, so that your solution is better or state of the art comparatively other research works, so that somebody can look into that. Then R&D seems to be a right direction in this particular thing, so that you will able to achieve something. Now I'm stopping here. This is the personal information. Mail ID is given. If anyone have a doubt, even few research publication we have done with respect to adversarial sample creation, etc. But in the interest of time, I could not explain how do we create an adversarial sample, but they can easily check my Google Scholars, so that they will understand. Okay, I'm stopping here. Thank you, everyone. And any doubt, they can ask me. I have another 2 minutes. Anyone have any doubt, they can ask. Is anyone have any doubt? Suppose if unable to ask now, you can email me so that I can answer also later on these topics which I covered today and in my earlier session. Okay, sir. If there is no doubt, I am stopping. Venkatramulu, sir. Thank you, sir.
Yeah,
Thank you.
Thank you, Venkana sir.
Thank you. Thank you.
So,
thank you.
A wonderful session. So you have given a good inputs on adversarial AI and attacks and how to provide the solutions. So you given a beautiful solutions for security. Yeah, thank you,
Sir,
thank
thank you.
Venkana sir.
Thank you, sir. Thank you, sir. Good night.
Yeah, good night.